What is going on, everybody? Welcome to part 8 of our data analysis with Python and Pandas tutorial series. In this part, what we're going to be talking about is creating, we're going to do percent change, but mainly our idea here is to create a correlation table. But we're actually going to try to cover quite a few things all at once here, so let's get started. First of all, this is basically starting code up to this point. We don't really, we can keep the pickle in, I suppose, if we want, but really what we want to do is let's just delete all of this, delete this, and we'll go with that. So HPI data equals pd.read pickle and so on. So now that we've got that information, what we're going to go ahead and do is first maybe we wouldn't mind peeking at the data, but before we peek at the data with maybe matplotlib, we're going to talk about modifying columns. So up to this point we haven't really modified columns within pandas, but modifying columns is really simple and fast. So for example, we can start a new column basically by doing something like this: HPI data, and then we'll say tx2 equals HPI underscore data, and then we can say, TX for Texas, so TX like this, times 2. Then we could print, and then we can reference just those two columns. So we'll say we'll print HPI data, and then square brackets, more square brackets, and we're going to reference TX2. Well, actually, we'll do TX2 second, and then TX. Save and run that just to get to this point, and we find that indeed we've got a TX, TX2, and it is a multiple. Now, of course, we don't have to multiply. We don't have to make a new column. We could say TX like that, and then do this, and this, run, and now well, you can't see the original, but if you recall from before, this is double what the original numbers were. So we can do that. Now, that's how we can kind of just modify the columns if we want to perform calculations, but I'll show you how we can apply a calculation to entire data frames and all that, and it's fast. So first what we're going to do is we'll go ahead and get rid of those, and now we'll go to the very top of our script. We're going to import matplotlib.pyplot as PLT. From matplotlib, we're going to import style, and then we're going to do style.use, and you can use what you want. I like 538. But ggply is good too, and so are many others. So we'll do that. Then we'll come down to the very bottom. This defines HPI data. You can plot an entire data frame doing HPI data.plot. Boom! Then we're going to remove the legend because it'll just get in our way. So plt.legend.remove, and then plt.show. Now, our data should in theory be relatively normalized, right, on the same-ish scale, so we can plot the entire data frame, no problem, or so we're expecting. So there it is. Okay, so this is all of our data for housing price index. So I mean, relatively they all kind of follow the same-ish path. Obviously there's major difference, right? We've got some that are 225, and then one is all the way, at the peak here, 225. Coming down here, we got one that's at 104, so very little difference. One thing to note, though, is it seems like everything converges right here, right? So we can zoom into that point, and I mean everything, it perfectly converges right there, and it just so happens to be on the perfect 100. So what's happening is this is basically the starting point for all the calculations. These are calculated in reverse, basically, and these are calculated from the future, starting at this, 2000. So we could either stick with that and have all the data be at a perfect 100.0 on that date, or we could use percent change starting from here and measure everything in percent change throughout time. So we'll close out of this. Now, what we're going to do is we can close. Basically, we don't need, well, we kind of want to plot everything. So let's go up to our grab initial state data, and basically once we get this data frame, we're going to convert it to percent change. So at least initially, the way that you do that is like this. We could say df equals df dot pct underscore change, and we can go ahead and run that. But what you're going to see is that the data kind of looks a little, well, let's just do this. Let's do this, copy, paste, and as it comes out, we're going to find that's not quite what we want. So percent change can mean a lot of things. It can mean from a starting value. It could also mean at every point, right? So from this point to the next point, how much has the percent changed? It turns out with pandas, when you just apply a % change like we've done, actually I didn't want to save a new data frame. Well, I guess it doesn't really matter in the end. We'll just let this one run through. Didn't want to save a new, is this, did it save? I'm trying to think. That is a % change, but this is not what I wanted. I don't think. Let me go back over here. This isn't what should have popped up. Let me close this. Fittystates. Oh, okay, so it saved it to fittystates.pickle. Right. So we need to read pickle fittystates.pickle. Hopefully now. And then let's not grab initial data. Let's try that again. Right. Okay. So this is that % change. Now, of course, you could use this, and this might turn out to actually be the more useful version as we go down the line. Who knows? So we could look into using this specific information here. And in fact, I'm going to go ahead and save that. We'll come over to the sample code here, fittystates pickle, and then I'm going to copy paste, and I'm just going to rename this to fittystates PCT change df. Hopefully that'll make me remember that was the percentage change against the entire data frame. But that again is not quite what I was hoping for. Kind of what I want is to see the percentage change being applied from the starting value. So how might we do that to the entire data frame? Okay, going back, starting over here. We will allow this to run, but first we need to make the change. So this is df equals, so we grab the data frame, fine. Next, what we're going to do is we're going to say df, and every data frame has only one column, and that is the column for that states abbreviation. So we're going to say df abbv, and we're going to say that is equal to, and this will be a long one, but it's percent change formula. Percent change, new minus the old, divided by the old, times 100. So that's percent change. So then we're going to say df abbv, new minus the old, or the, in our case, original, abbv, new minus the old, 0. So new minus the old, and then divided by the old, df abbv, 0, divided by the old, times 100. Okay, that is percent change. That's all you have to do. That'll populate the data frame for us, no problem. I'm going to save this as fittystates3, and this will be fittystates3, and then we should be all set. So let's go ahead and, yeah, we'll save that. We'll run that, and we are grabbing initial data. So after all of this runs, we should get a graph, and instead of the initial housing price index and the initial, point-by-point percent change, this time we'll get the percentage change from that first year, which was, I think, 1975. So that'll be kind of interesting. So then, after we've got all the data sets in, so there we go. So now this is percent change starting from the 0 point, right? So that I kind of like doing that, moving that starting point to the very beginning, rather than having it all converge at 100 at some random point along the way. But we might find that this is the wrong way to do it. Who knows? Anyways, so there you go. Now, what we're going to do is we might end up actually wanting to compare. Right, you've got all of these. These are basically the every state is being graphed. Now it looks like they pretty much follow each other, right? They're probably very highly correlated. But then the other thing that we want to go ahead and add is the entire United States housing price index, so the conglomerate. So we could actually average all these together and do that. But let's go ahead and grab the official one and just make sure that we got the right information. So now we're going to make a new function, and this is how we would add new information. In this case, this is just US-wide HPI, but maybe you want to incorporate demographics like crime rate, literacy rates. Maybe you want to bring in the GDPs of every state or the GDP of the entire country, the S&P 500, and so on. This will be the method that you would use to do it. So we'll say, okay, we want to bring in a new bit of data. We'll call this define HPI underscore, and we'll call this benchmark because this is for the entire United States. We'll say df equals, and we'll do this. Let's just copy this, paste. Instead of just query, we'll say what we're going to bring in is FMAC. That's for Freddie Mac, HPI underscore USA. Then we want that to also be the percentage change formula. So we'll copy that, paste that here, and then instead of ABBV, this is United States. That's just the name of the column. If you didn't know the name of that column, what you would do is usually, you'd pull by this ticker, and then you could just print df.headout and look, what are they calling that column? You can also look on Quandl, like let's go to Quandl real quick, and then USHPI maybe would work. Let's try that. I bring out Quandl for you guys. I'm trying to find Freddie Mac in this list. I don't see Freddie Mac. United States Housing Price Index. If this doesn't give us one, we'll just, let's see. Yeah, so here we go. This is only from, okay, yeah, this is what we want right here. This is probably exactly what we're using, right? So you can look down here, and you can see latest values. Date, obviously, is our index, and then you can see, well, one of the columns is United States. Okay, so there you go. Closing that. So now we have HPI benchmark. And then what can we do to add that, right? Because this is now in the same format as that original one, but we're pulling this after the fact, right? After it's already been made into this pickle. And by the way, before we forget, let's comment out grab initial state data. We don't need to grab that again. Now what we'll do is we could add this, or we could plot it all on its own. Now, to plot it all on its own, I'm trying to think if I really want to plot it all on its own or if I want to just add it. But you could just do a join. But let's say you had a different data set that you did want to maybe plot, separately or something like that. What you could do is something like this. Like we could say, let's do fig equals plt.figure, and then we'll say ax1 is equal to plt.subplot2grid. This just creates a grid. We're going to say the grid itself is a 1 by 1. This is a grid of basically subplots. This is how you could organize subplots in matplotlib. You don't really have to worry about this for this series to kind of follow through. If you want to know more about matplotlib, check out the matplot. There's a long matplotlib tutorial series on pythonprogramming.net and on my channel. Just recently updated it actually. So if you want to check out and learn more about plotting with matplotlib, check that out. Anyway, this makes a 1 by 1 grid, and then the next parameter here is where you want your specific grid for AX1 to start. We're going to start at 0, 0. That's fine. Now, we have HPI data is grabbed here. We plot that, and we'll just say plot. You can say AX for axes. We want it to be plotted on axis 1. Then we're going to, actually what we need to do is come up here to our HPI benchmark. We forgot to return df. Coming back down to where we're working. Now we're going to say this is where we grab our data, and then we're going to say benchmark equals HPI underscore benchmark. Generally, when I do graphing and stuff like that, I usually carry all the data kind of together. So this is where we're generating the data, and then I plot all the data kind of together, and then we do like the main PLT to show and legends and all that together. So anyway. So then we'll say benchmark.plot. Again, we're going to plot to AX equals AX1. We're going to say the color equals, and K is used for black because B is blue, so they used K for black. And then line width equals 10, so we'll definitely see this benchmark line. Legend remove, plt.show, good to go. No longer running through that really long one, so should be all set. Should be anyway. There we go. Okay, so now you can see this big thick black line here. That is our benchmark as it appears. Yeah, it looks like the entire, the average is very correlated with everything else. There it is, smack in the middle basically of everybody. Now finally, what we can do, ignoring that we haven't added the benchmark just yet, but what we can do is we can actually correlate all of our data with each other. And find out just how correlated every state is to each other. So we're going to not be graphing anymore. So let's do this. So we still have HPI data. And the way that you can do all kinds of stats on data frames. The first one that we're just going to do here is going to be just correlation. So what we can say is HPI underscore state underscore correlation equals HPI underscore data.corr. This will generate a correlation table for all of the columns, and let's go ahead and print this, save and run that, and there you go. So it's a very large table. Obviously you've got every state down here and then every state, so it's a 50 by 50 basically, and then you can see how correlated is everybody with each other. So we've got Arizona here, it's 92% correlated here with Alabama. I can't remember now. I can't remember which one was ALAK. You got like Alabama, Alaska, Arkansas with the K. So let's go ahead and go Colorado with California, 92.5% correlated. These are all really high. Okay, you could look through here and try to find like the smallest number. Like here we've got a 79% correlation between Texas and Nevada. Okay, and so on. And another thing that you can do is you can actually find more information on a data frame by doing this. You can say, because HPI state correlation, that's a data frame. So you can say that plus or dot describe, and then we can print that out as well. Print. So what this does is describes the data frame. It'll give you a bunch of information. So for every column, it gives you some information. It tells you how many rows are there, what's the average of all the data there, what's the standard deviation, what's the lowest value, what's value, the 25th percent, quartile, or the first quartile, 50th percentage number, so the median. Then you've got 75%, and the max is 1. And the reason why max is always 1 is because, Utah is 100% perfectly correlated with Utah. Okay, so you always have that. But the interesting number is min. So you can see here the lowest correlation for like Washington with anyone else is 86%. That's incredibly correlated with every state. So every state is clearly following each other very closely. Here's one that's pretty low. Let's say AK with its minimum is 74%. Now, even then, 74% is pretty darn correlated. But that's the minimum, and I think that's one of the lowest actually correlated in all of these pretty much. I'm not sure anybody's lower than 74. So bottom line, every state is very strongly correlated with every other state. So that's pretty interesting data. So if you have two states that start to diverge, the one that's falling is probably one that you can safely invest in. As long as you're confident in the housing market long term, you would go with the one that's diverging down. Okay, so it's kind of hard to short the housing market. You can short the housing market though. There's you can short like builders stocks, and then there's also a housing market that actually literally shorts. I forget who they are shorting, but it's like SRS, I think, is the ticker for them. Anyway, maybe we'll talk more on that way later. But so anyways, you can do correlation like that. And so as we can see, every state is highly correlated with each other. So the entire housing market follows itself very significantly. Okay. So anyway, I think we'll cut this tutorial off here as far as doing correlation, all that. In the next tutorial, what we'll cover is resampling data. There's a few reasons why we're going to be resampling data in this series, but the idea of resampling is to take maybe you've got data that's coming in every millisecond, but really you only need data to be monthly or something. That you can use resampling for that reason to kind of change the granularity of data sets. Anyway, long tutorial here, lots of stuff kind of running through here, so if you have questions, comments, problems, whatever, feel free to leave a comment below. Again, the written tutorial is also posted. That's linked in the description, so if I left you behind somewhere, you can always check that one out. Anyway, questions, comments below. Otherwise, as always, thanks for watching, thanks for all the support and subscriptions, and until next time.